Okay, so welcome to our today's lecture. So the today's lecture is gonna be on similarity or dissimilarity measures. So we are gonna analyze the data using R programming, but the topic is similarity and dissimilarity measure. So what is similarity measure and dissimilarity measure? So in data science, mostly in the data science or data mining applications, the similarity measure is a way of measuring how data samples are related to or close to each other, right? So if your intention is to measure how data samples are related or close to each other, then you can use a measure, and this measure is called the similarity measure. If your objective is to find the similarity, right, among the data samples, then you can use a measure. That measure is called the similarity measure. So similarity measure is mostly used in the data science applications or data mining applications. So on the other hand, what is called dissimilarity measure? So this is the opposite of the similarity measure, but the objective is same. On the other hand, the dissimilarity measure is to tell you how much the data objects are distinct, right? That means are dissimilar to each other. So in the similarity measure, you can find the objects which are very close to each other. But on the other hand, the dissimilarity measures will tell you how much the data objects or data samples are related to each other. So moreover, these terms are often used in clustering when similar data samples are grouped into one, right? That means you can use these two terms, similarity measures and distance measure, right? You can use these two terms in clustering. Like if you want to do clustering for your data science or data mining applications, you can use these two tools, okay? When your objective specifically for the clustering. So for the clustering problem in data science, or for the clustering problem in data mining applications, you can often use similarity measure or dissimilarity measure. So what are the different characteristics of similarity measure and dissimilarity measure? So as you can see in the right smart side of my slide, as in the similarity measure, numerical measures of how alike two data objects are, and the value is higher when objects are more alike. So when the objects are more alike, then the value will be of the objects will be higher, right? But often the range of the similarity measures is 0 to 1. That means it cannot exceed the range 0 to 1. So these are some of the characteristics of similarity measure, right? So what's about the dissimilarity measure? So you can say the another name of the dissimilarity measure is called the distance measure. So numerical measures of how different two objects are lower, the value will be lower when objects are more alike, right? And minimum dissimilarity is often 0, but there is no limit like the upper limit. So the upper limit varies based on your data size or based on the type of your data. So what we can conclude from here, for the similarity measure, it ranges from 0 to 1, but for the dissimilarity measure, right, the ranges, I think the minimum ranges is 0, but the maximum ranges is it varies from your analysis of your data. Like it can be any value. There is no range for the dissimilarity measure, right? So the proximity refers to a similarity or dissimilarity. So this is the basic background of a similarity measure and dissimilarity measure. So what is the conclusion from here? You can use similarity and dissimilarity, both measures, for the clustering problem in data science or data mining applications. So what so if the mathematical notation, if we can take a look at mathematical definition, right? So you can say the similarity between two tuples, right, or two objects, or maybe or series of data, Ti and Tj. So you can mathematically define or denote similarity of Ti and Tj, right? Or the similarity between Ti and Tj in a data set D or database D is a mapping from D by D to the range 0 to 1. Thus, you can simplify the form like similarity of Ti Tj belongs to 0 to 1 because the range of the similarity measures ranges from 0 to 1. So what is the object? The object is to define the similarity mapping such that documents that is more alike have a higher similarity value. You have to make a concentration here, like if the value is higher, that means if you find the similarity value is higher, then you can conclude that the documents you are studying, right, that is more alike. So the objects, when you see the objects are more alike, it will come from a higher similarity value, right? Thus, the following are the desirable characteristics of a good similarity measure. So what are the desirable characteristics of similarity measure, right? So the similarity between Ti and Tj will be 1, right? It can be 0. It can be the similarity between Ti Tj can be less than similarity of Ti Tk. When it will occur? So if it is 0, you can conclude the two objects are not alike at all, right? And if the similarity between Ti and Tj less than similarity of Ti Tk, then you can conclude that the object Ti is more alike Tk than it is like Tj, right? So these are some of the basic characteristics, or you can say these are the desirable characteristics of similarity measures, right? So based on the output you are gonna get from your data, right? So you can interpret the similarity between two objects, even the three objects, right? So it will depend on your dimension of data. But what you can do from here, you can find the clustering, right? Clustering means the more similar objects. So you can divide your data into several groups. So each group are called the cluster, right? So in real life research or in data mining application, even in the data science, so we are living in a big data era, right? So the data size or the dimension of the data is very big. So sometimes we need to make some cluster. We want to see the homogeneous characteristics among or between the cluster. In that case, similarity measure will give you a big hand, right? Or will help you a lot to find the optimum cluster, or to find a important cluster, or to find a cluster of your interest, right? How you can conclude? You can take a look some of the characteristics. So based on the characteristics, you can effectively find your desirable cluster, right? Based on the similarity measures. Okay. So what are the different similarity measures? So commonly there are four similarity measures are used. What are those? Number one is a dice, Jaccard, cosine, and overlap, right? So these are the mathematical notation of each similarity measure. So here, what we are doing here, we are measuring two objects, spatially, or two tuples, Ti and Tj, right? So that these two objects were our interest is to measure these two objects, right? Whether there is a similarity between Ti and Tj. So these are some of the mathematical notations you can calculate, or you can use for the calculation for your data, right? So what are the similarity measures? So there are four different kinds of similarity measures mostly used in the data science or data mining application: dice, Jaccard, cosine, and overlap. So what's about the distance or dissimilarity measure? So there are 6 types of distance or dissimilarity measures you can use for your real life application of data science or clustering problem, right? So what are those? Number one is the Euclidean distance, Manhattan distance, Minkowski distance, right? City block, Canberra, and CJK Naukowski distance. So these are some of the 6 distances, or you better to say these are the distance or dissimilarity measures, right? You can use for the clustering problem specifically. If your objective is to find the similar or dissimilar objects of your study, right? So These are the distance or dissimilarity measures. So now we'll take a look, how can we solve some real life data? So in R programming, okay? So you can use R definitely to find your solution, right? So consider we have 3 data sets are here. So the T1 is the number 1 data set, T2 is the number 2 data set, right? T3 is the number 3 data sets. I think you already know about this data set because in our last exam, maybe we introduced or we tried to use this data set for your exam purpose, right? If I am not wrong. So anyway, so how can we measure these 3 data sets, right? Using the similarity measure or distance measure. So today's class will be based on the just a simple calculation using the R programming, right? But what you can do, maybe you can use some package. I think you already know about some of the statistical packages used in the R programming, but today's class will be based on the manual calculation, right? So I recommend you to use some particular package. I think there are many packages available now for calculation of similarity and distance measure, right? So what you can do, you can just update your package or you can install your package from R, right? Then after installing the package, you can calculate the similarity measures or dissimilarity measures. It's very easily, right? So yeah, it will come later. You can try at your home, but today I'm gonna calculate manually. So I just want to give you some idea of some of the hands-on training, right? Some of the basic calculation using the R programming. Okay, so what are the data sets are here? So suppose you are given 3 data set, T1, T2, and T3, right? Do you think the data sets are correctly input here? What do you think? Anyone? You have to respond quickly, otherwise I have to tell myself. I told you, you are given 3 data set in R. How can you read the data set in R? This is correct or not? Can you see my slide or not? Can you see the screen?
যেগুলোতে ডাটা সেট গুলো ঠিক করে নিতে হবে বিয়োগ করা
The data set input হয়েছে স্যার
No need to clean the data set. That the data set is very okay. Okay. I told you, is the data set is correct? Because
Yes, sir.
these the data set are displayed in the R programming. Try to answer in English. Mind it, this is recording. So what the 3 types of data sets are here, right? I told you, is data set are correctly written in the R programming? This might be correct in your paper, right? But what's about the R programming? This data is okay. Anyway, so you have to use the column, right? So this is the column. So in R, right, is data set you have to write in the column. So T1 is equal to column. That means the column vector. This is a vector, right? Or series of data. It's not a series of data, it's a data set, right? Consisting of several objects. So these are the objects or these are the values, right? You see now column. So now the data set is okay. You see there is no cross sign in the left side, right? So the similar fashion, you have to enter your data in R programming. So this is the data set 2, and finally the number 3 data set is here. Clear?
yes
So these are the 3 data sets. We have to now we are gonna use this data set for the measurement of similarity measures. So how can we calculate these similarity measures? So that the calculation is very easy, like just you have to calculate like some of the basic calculation, product, sum, right, deviation, something like this. So just you have to write those things or those function in the R programming. So first we are gonna calculate these data sets using the dissimilarity measures, right? The first one, number 1, dice. So for that you need to know the formula, right? So we can take a look or go back to the formula again. So what was the formula for dice? So this is the formula, right? So in the numerator there is something, in the denominator there is something. So what is this? Like in the numerator you have to sum over, right, the product term of TIH and TJH, right? But in the denominator, what you have to do, the square term of ti square summated over the square term of ti square and plus the summation over ti square j is, right? So these are some of the calculation or formula for calculating the similarity measures among the three data sets, right? Using the dice. Now we are gonna go in the R programming to calculate it. Okay, mind it. So manual calculation will be done here. So what you have to do first, suppose you have to define a variable, right? So you can do it like I am doing here. So suppose I am calculating similarity among, right? So you can write in your own way. So I am writing this way, similarity of between. So this is the name of the variable, right? Just this is the name of the something, like you can do anything from here. So similarity between, because we have three data set, T1, T2, and T3, right? First, you have to calculate similarity between T1 and T2, right? Then you can calculate similarity between T1 and T3. Finally, you can calculate similarity between T2 and T3, because you have three data sets. So how many combination is possible here? There are three combinations are possible here. Number one is similarity between T1 and T2. T1 and these two, right? T1 and T2. Then you can calculate T2 and T3. And finally, you can calculate T1 and T3. So these three combinations are possible. So you have to calculate these three similarity measures, right? Between three types of dimension of the similarity, right? The first one, I'm going to calculate similarity between T1 and T2. Clear? So in the R programming, this is the variable name. So after the later part will be mainly the calculation. So you can start with less than hyphen, no problem. Even you can start with equal. Okay. So here I am using the equal. It's up to you what you want to use. So can you remember the formula? In the numerator, what was there? Tell me. Tell me someone. What was the formula in the numerator?
Sum of T1 into T2.
Huh?
Sum of 2 into sum of T1 into T2.
Tell me slowly. And you have to follow me, right? I am writing, then you have to tell, okay? So T into, then?
Sum of
Wait,
T1.
good, wait. Tell me my writing, then you can tell. Sum of, so this is the sum of, then?
T1 into T2.
Sorry. T1 into T2. Then what?
Divided by sum of,
good, sum of
T1 square.
T1. So what will be the square for R programming? Do you know?
Square.
Is that okay?
Yes, sir.
Okay, then what happens?
Into T2 square.
It's not into, maybe. Or sum.
Plus, sir. Sum, sir.
Okay, good. Sum plus
T2
sum
square.
of
Sum of T2 square.
T2 square. Is that finished?
Yes, sir.
Okay, just try to take a look over the first bracket. Is that all first bracket is okay here? How many first bracket you have to use here? Quickly, tell me quickly. Okay, maybe I can use one first bracket here, right? Then, because this is the dividation, right? So you have to use another first bracket here. What do you think?
Yes, sir.
What do you think?
Yes, sir.
Yes, sir.
I think now it's okay.
It's okay.
How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I think it's fine, right? So now how can we run this one, this code? It's very easy, just run this one. Okay, object T1 is not found. Why is not found? I did not run the command maybe in before, right? So try to run this one. Okay, so you can also try to see like this. Maybe you can write again T1. Okay, suppose you want to see the value of the T1, you can just run T1. Okay, the T1 will come here. Or if you want to, if you save your time, you can write in one sentence. Just
semicolon Q1.
exactly. So this is the another thing. So you have to run all the data, right? All the data. So T2, then T3. Now we can run this one. Okay, good. So we did not get any value. Why we didn't get any value here? You see, we didn't get any value. Why? What's the reason?
So we have to run this.
We ran already, but okay. So
again
you have to run this one, right? So in the one line, you can run this one, no problem. Okay, I think you will. So what's the value is gonna be? Any idea? The value must be less than 1, right?
0 to 1.
0 to 1, exactly. So what is the value? Minus 0.69. Is it okay? Is it okay?
No, sir.
0 to 1.
Minus 0 to 1.
Anyway, that you can just take a look of the data. Maybe here some of the problems, or you can just take a look that data range again. No problem. The calculation is okay here, right? So this is the way you can use the dissimilarity measure to find your similarity value, right? So what will be the Jaccard? Someone just tell me. Oh, what will be the next one? So you have to do the same thing.
T1 and T3.
T1 and
T3.
T1 and T3. So what will be the formula for here? Here it
Same
will be
formula,
T3.
just
okay, and
T3.
this one, and what will be the second one? I think here T3, right?
T3.
T3, right? The
Yes.
same formula. So it will be T3. Is it okay?
Okay, sir.
Try to run this one. What is the value? 0.83. 0.83. So what will be the final one? The final one will be
T2, T3.
T2 and T3.
T2 and T2. You have to just replace T1 and T2, right? Is it okay?
Okay, sir.
Good. So the value is minus 0.50. Anyway, so these are the some of the measurements. So you can conclude or you can interpret in a good way, right? Which objects are similar to each other? The similar objects are the similar objects T1 and between T2, or the similarity you can find between T1, T2, or T1, T3, or T2 and T3. So you have to take a look on the values, right? As I told you in the previous slides, right? The more value, if the value is higher or close to 1, I think the objects will be more alike, will be more
Similar.
alike. So you can interpret now based on the calculated value, right? So let's go for the Jaccard similarity. Tell me. So we are gonna do the same thing here, right? Just the formula will be different, right? So what will be the formula then for the Jaccard? Tell me.
Sum of T1 into T2.
There is no 2 into sum. What is the formula?
If there is no 2.
Huh? Okay.
2 nice, sir.
There is no 2 right over here. So what I can do here? Tell me the formula.
Sum of T1 into T2.
Sum of T1 into
T2
then
divided by sum of T1 square
plus
T2 square, sum of T2 square minus.
wait. Follow me. Sum of
T1 into T2.
Sum of T1, right? Into what? Into sum of, right? Again. Sum of T2. Is it okay?
Yes, sir.
check the formula again. The first one, right? The sum of T1 into T2, right? Divided by sum of T1 square plus sum of T2 square minus sum of T1 into sum of T2, right? So this will be okay. I think how many brackets are here? 1, 2, 3, right? 1, 2, 3. Okay. Is it okay? Huh? Not okay? I think it's okay. Anyway, so the what's about the second one? The second one will be how what? Tell me.
Sir, maybe something wrong.
What wrong?
স্যার শেষে শুধু সাম অফ
Try
টি
to tell
ওয়ান
me
টি
in
টু হবে
English.
স্যার আলাদা করে সাম হবে না স্যার
Okay, you can
মাইনাস মাইনাস সাম অফ টি ওয়ান ইন্টু টি টু
What do you think? The first one? You are talking about the first one?
মাইনাস সাম ওয়ান টি ওয়ান ইন্টু টি টু
The minus
Sum of
numerator,
T1 into T2.
minus numerator,
This one.
minus
Yes, sir.
numerator.
Here.
Yes, sir.
Minus.
Sum of T1 into T2.
So you are telling me
That
like
means
no, you need to
numerator.
use the sum here.
Yes, sir. Yes, sir. That's
Here. Okay, let's see.
ইয়েস স্যার
Minus 2.5. Anyway, just you can make it correct. Okay, I'm just giving you some clue. So what is the second one? T1 and T3. Tell me quickly. So it will be just what?
3.
Just it will be 3. So I have to copy
Plus
this one.
23.
Okay, so it will be T3. T3, right?
T3.
T3. Okay, finish.
T3.
Okay. Okay, I think this the value is correct. Seems very correct. Okay, and the final one, you have to replace T1
T1.
with T2, right? Just T2, right? Is it okay or no? Okay, T2 and T2. Okay, so the value will be minus 0.38. Anyway, so this is the
T2,
way.
T1, T2 হবে।
টি টু টি থ্রি হবে স্যার
minus T2, T3.
Okay, now okay.
Yes, sir.
Okay.
Sir.
So this is the result, right? So we have used two similarity measures are here, right? So maybe you can do it the similar fashion using the similar fashion for cosine and overlap. I think you have to just do some calculation, right? I think can you do it right now? Or I need to show you? I think it's very easy, just the calculation, right? So better we can try for the this one dissimilarity measure, Euclidean distance, right? Euclidean distance. So we try here for the Euclidean distance. Okay. So try this one. Write down and tell me these three measure quickly. So you have to be quick. Tell me. So using the
Square root of
huh?
square root
Yes.
of
So how can we write in the R like SQRT?
SQRT.
Okay. So I can give you a bracket, first bracket. So inside you have to tell me something again. Sum of very good.
T1 minus T2 whole square.
T1 minus T2
Whole square.
whole square, right? So you have to write another bracket here, maybe, right? Then whole square. Then
That is
finish. Oh, good. The value is 26.5.03. Do you think the value is correct?
no, sir.
Do you think the value is correct? We just calculated here using the one of the dissimilarity measure. You can using the Euclidean distance.
No, sir.
Why no?
Sir, 0 থেকে 1 এর মধ্যে হবে স্যার।
No. This is not correct.
No, sir.
It's
No,
For
minimum
the
zero,
similarity
maximum,
measure, right?
minimum
0 to
dissimilarity is 1.
minimum zero, maximum varies.
Yeah, maximum can be of any value. Okay, so in the last class, we did not make you clear. I just told you about the similarity measure, right? For the dissimilarity measure, I did not even concentrate. So most of the students who just try to calculate, I think your calculation was okay, right? So I have to revise the result again. So maybe you will get more marks what you got right now. Okay. Anyway, you did not bad. Just I think the exam was okay. Anyway, so you can solve those problems using the similar fractions, right? So what you have to do here? So suppose I'm gonna copy again. So now you have to find for the other three measures, right? So the second one will be for T1 and T3, and the final one will be T2 for T3. Suppose T1 for T3. Okay. So T3. Okay. So T3. And this one will be T2 and T3. So maybe I can change the order. Let's try. Let's try. T3, right? And T3. Okay. I can just run these three values and what happens. So the first one is 265.03, right? The second one between T1 and T3 is 93.1, and the finally T3 and T2 358.13. Okay, so these are the calculation I just show you today using dissimilarity measure, Jaccard. Okay, so you can complete the other jobs, right, using cosine and overlap. And for the dissimilarity measures, the remaining measures you can calculate by yourself, right? So these calculations are not difficult, but the problem is I just tried to show you using a manual calculation. I think you can Google it, you will find some package. Okay, so how to install a package? So you can just install a package something like this.
Install packages.
Exactly, install dot
Packages.
So you have to just write down here the name of the package. Okay, sometimes you need to update the package as well, so you can also update your package. So update the package name. Okay, but you have to find out the suitable package to solve similarity and dissimilarity measures. So what will be the difference between this calculation and using a package? Package for the, if you want to use package, that's gonna be very smooth, and you need to, like, you will have a very little time to solve the problem. How? Just you have to install the package first, you have to read the data, right? Then just you have to, I think only 1 or 2 sentences, you will have all the calculations. So that is the beauty, or that is the usefulness of packages, right? So you need to use packages. So try to find some packages for solving similarity measures. So what do you think? Like here, the data set is small, right? This is not really a big data, but in real life, you have a lot of data, a lot, right? So then what you are gonna do? So there is no alternative of using package. Okay. Suppose the dimension of your data is a huge data, so you cannot solve using your hand, like the hand calculation. It's very difficult. You cannot do it, right? The way we calculate here, it was very easy for us because our data size was very small. But what's about your data is like very big data in the data science or the data mining applications, right? The data is the issue, major issue over there. So if the data size is very big, right, what you can do? There is no alternative of using what? Of using packages, right? So this is the thing, you have to use the packages, right? So dear students, so this is all about the today's class. So if you have any question, maybe we can have a discussion here. Do you have any question?